Today we will discuss about another fat soluble vitamin, that is vitamin A. It can be asked in the form of long question of 10 marks. So the question will be like, describe sources, daily requirement, biochemical function and deficiency features of vitamin A. So it's a fat soluble vitamin. Its active form is present only in the animal tissues. So another name of vitamin is commonly known as the retinol. So all the compounds which have vitamin A like activity combinedly they are known as the retinoids. And another reason for that is that vitamin A is required in the retina function. So that's why this particular name has come. There are three different forms of vitamin A are present. One is alcohol variety, which is known as the retinol. Then there is aldehyde variety, which is known as the retinal. And third one is an acid derivative, which is known as the retinoic acid. Each variety has its important role and function in our body, and they are interconvertible by the help of various enzymes. So just like vitamin D, where it was a precursor for vitamin D was cholesterol. 7-dehydrocholesterol was giving rise to cholesterol. So vitamin A, it's also a cholesterol derivative. It has structure similarity with it. But here the precursor form is known as the carotenes. Okay. So provitamin form of vitamin A is known as the carotene, which is present mostly in the plant foods, and the carotenes which are received by the plant foods will be converted to retinal by enzyme dioxygenase. Further on, this retinal can be converted to retinol by the enzyme reductase. So active form of vitamin A, retinol, retinal and retinoic acid, all three are known as the active form of vitamin A. Out of this, retinol and retinoic acid, they have steroid hormone like activity. So they will have a receptor at the target organs, they will bind with them and they will perform their action accordingly. They are mainly concerned with the growth and differentiation process of various tissues that we will discuss later on. The third form, that is the retinal, it is the main form of vitamin A which helps us in process of vision. So because of retinal, the visual cycle takes place and we able to see the or our vision for function works accordingly. Storage form of vitamin A is retinol palmitate. That means retinol will bind with certain fatty acids and then it will be stored in the liver. So in visual process, the pigment which is responsible for the vision is known as the rhodopsin. I repeat, rhodopsin. This rhodopsin is made up of opsin and 11-cis retinal. So this 11-cis retinal is the active form of vitamin A which helps in formation of visual pigment rhodopsin. This rhodopsin absorbs the light and generates the visual signals. So the process of this is known as the visual cycle, famously known as the Wald's visual cycle, that we will discuss in the functions of vitamin A. So this is the structure of vitamin A. It's a precursor, beta carotene. On this, the dioxygenase enzyme will act and it will convert this beta carotene into 11-cis retinal and then into all trans retinal. This retinol and retinal are interconvertible by the help of enzyme reductase, and retinal will be converted to retinoic acid to perform specific functions. Daily requirement. So RDA for vitamin A in adults, it is around 750 to 1000 microgram per day. In children it is around 400 to 600, and in pregnancy we require vitamin A in higher quantity, around 1000 microgram per day. You can remember the same units in the form of retinol equivalent. So one retinol equivalent will be equivalent to 1 microgram of retinol. Dietary sources. So mainly in case of vegetables or plants, mainly green vegetables and the yellow fruits like papaya, mango, pumpkins, and obviously the carrots are the rich source of vitamin A. In animal sources, milk, butter, cheese, and non-vegetarian sources like fish oil or fish liver are the main sources of vitamin A. So this particular slide you can read or understand later on, because we will discuss this each and every aspect of vitamin A related with its storage, its function, also transportation form, and its various action on other target tissues. So this particular slide is kind of a summary of vitamin A, which you can read or understand at the end of the topic. Now coming to the absorption and transportation part of vitamin A. So in animal foods, vitamin A will be present in retinol ester form. So that means it will contain the alcoholic form of vitamin A, that is retinol and fatty acid. In plants, it is present in beta carotene forms, which is the provitamin form. So this ester form of retinol will be hydrolyzed into free fatty acid and free retinol in our body by help of certain gastric enzymes. After that, it will be absorbed into the intestinal mucosal cells. So in mucosal cells, once again this free retinol and free fatty acid will bind and they will form retinol ester. So retinol ester, which has been hydrolyzed, once again will be ligated here. In plant foods, the beta carotene which is present, it will be absorbed into the mucosal cell. Then with the help of dioxygenase enzyme, it will be converted to retinal, and retinal will be converted to retinol by reductase enzyme. This retinol can bind with the free fatty acid and forms the retinol ester. After that, from the mucosal cell, this retinol ester will be transported to liver via blood with the help of chylomicron. So chylomicron is a lipoprotein which helps in transportation of certain lipids or lipid-like compound such as the vitamin A. So chylomicron will take this retinol ester, this Re represents the retinol ester, then via blood it will go into the liver. So in the liver, these hepatocytes, there will be free retinol formation. The fatty acid will be liberated from the complex and then we will have free retinol. This free retinol will bind with a protein RBP, that is the retinol binding protein. Then this retinol binding protein from liver, it will transfer this retinol to the target cells such as the rod cells or cone cells of the retina, in the skin, in the gonads, etc. etc. So retinol binding protein will be necessary for the action of retinol to the target tissue. Okay, so this is about the absorption and transportation of vitamin A. So this particular slide shows the same thing which we have just now discussed. You can look at all these lines and you can write in this particular fashion about the absorption and transportation. So coming to the biochemical role of vitamin A. So main role of vitamin A is in the vision. So how does it help in vision function or visual cycle? So retina is the layer in the eye on which light falls and then we able to see any particular thing. So for that, under the retina we have two kind of cells, rod cells and the cone cells. Their physiology and their functional part you will be going to deal in physiology subject separately. We will just briefly outline the physiological role of rods and cones. So rods is responsible for the dim light vision and cones is responsible for the color vision. So as in the starting we mentioned that in retina we have a visual pigment which is known as the rhodopsin. It is the main visual protein responsible for the dim light vision in the rods. This rhodopsin is made up of 11 cis retinal and opsin. So this is the picture of rod cells. Here you have to remember one or two things. One is this one is the cyclic GMP dependent sodium and calcium channel, and another thing is the sodium potassium ATPase pump. So this particular channel has a role in visual process that we will understand by the Waltz visual cycle. So this is the Waltz visual cycle or the visual cycle, how vision process takes place. So if we see the biochemically what happens here, the rhodopsin, which is the visual pigment, it is made up of opsin and 11 cis retinal. So once there will be a light available, what this light will do, light will break down this rhodopsin into opsin. Also it will isomerize this 11 cis retinal into all trans retinal. So rhodopsin, which was made up of opsin and 11 cis retinal, out of that opsin will be liberated and this 11 cis retinal will be isomerized to all trans retinal. This all trans retinal can once again be isomerized to cis retinal by the retinal isomerase in retina, and this cis retinal will bind with opsin and then there will be formation of rhodopsin once again. So this cycle can be completed within the retina itself. Okay, so cycle will start with breakdown of rhodopsin into opsin and 11 cis retinal, then there will be isomerization to the trans, and once again there will be isomerization to the cis retinal. So trans to cis is by retinal isomerase, but cis to trans is by the photoisomerization, that is on exposure to light. But another way to complete this cycle is that this trans retinal can go to liver via blood. In liver, in the presence of enzyme alcohol dehydrogenase, this transretinal will be converted to retinol. Okay, so this aldehyde derivative has been converted to alcohol variety. This transretinol will be isomerized into cis retinol. Okay, by here the isomerase which is present in the liver. Okay, so the here it will be retinol isomerase, here it is retinal isomerase. Okay, good. So after that this retinol will be once again converted to cis retinal by same enzyme alcohol dehydrogenase, and this cis retinal goes to the retina and binds with the opsin and forms the rhodopsin once again. So the completion of this Waltz visual cycle takes place via two routes. One within the retina itself, which is shown here up to this part. In other part, via the route of blood, it can goes into the liver. It takes the help of enzyme alcohol dehydrogenase and then will be converted to rhodopsin once again. So in the retina, it is only the retinal part, but in the liver, it can gets converted to retinol part. So that is the one change you have to remember. So how does this leads to formation of a vision or visual cycle? So what is the thing we have to remember here is that generation of visual signal. So visual signal is generated due to hyperpolarization of the rod cell membrane following excitation by the light, and it will generate a signal. So here what happens actually, once there will be photo excitation by light, then rhodopsin is converted to finally opsin and 11 cis retinal. But in between it gets converted to several intermediate, and one of the main intermediate is the meta rhodopsin. Okay, so meta rhodopsin is the main thing which generates the visual signal. So this meta-rhodopsin, which is like a product of rhodopsin, it will be bind to another product, that is the transducin. Transducin is a G protein. So here if you see the rhodopsin, this is the rhodopsin. This particular pink color structure is rhodopsin. It will bind to another protein, that is the transducin. So this transducin has a two function. One, it can bind to GTP, and after some time it can break down the GTP. Okay, I repeat, transducin has a two function. It can bind with the GTP, okay, that is guanosine triphosphate, and it also can break down the GTP. So initially what will happen? Rhodopsin will bind with transducin. Then what will happen, the GDP which has been already bound to transducin will be replaced by the GTP. Okay, will be replaced by GTP. And this GTP, it will activate enzyme phosphodiesterase. Okay, it will activate the enzyme phosphodiesterase. So phosphodiesterase, which was inactive, it will become active. And what it does do, it does the breakdown of cyclic GMP to the GMP. Okay, so simple word you have to remember, rhodopsin binds with the transducin. Transducin will activate the phosphodiesterase enzyme, and phosphodiesterase enzyme will break down cyclic GMP into the normal GMP. So what is the role here? The low amount of cyclic GMP will lead to closure of sodium channel. It will lead to hyperpolarization of rod cell membrane, and then there will be generation of nerve impulse or optic signal. So if you see the structure of this particular rod cells, so here what happens when there is a low availability of cyclic GMP, okay, then the sodium channel closes, and closure of sodium channel will lead to hyperpolarization of rod cells, and it will be able to transmit the signal, optic signal. Okay, so this particular thing you have to remember. So hyperpolarization of rod cells is possible because of closing of sodium channel, and to close a sodium channel we have to lower the amount of cyclic GMP, and that is taking place once rhodopsin binds with the transducin. So try to read this particular cycle one or two times, then you will able to understand the process of optic signal. Now coming to the termination of signal. So to terminate a signal, obviously we have to increase the cyclic GMP level. So that is possible on the process of phosphorylation. So as I mentioned earlier, that this transducin, once it will bind to GTP, after sometimes it will have a GTPase activity. So what does it will do? It will lower the GTP amount after some time. So as the GTP will go down, the PDE will become inactive and the cyclic GMP will rise. So all this thing will be now reversed, and it will close the optic signal. Another process to arrest is that we have another inhibitory protein, that is the beta arrestin, that will bind with the rhodopsin, and then rhodopsin becomes inactive, that will lead to terminate optical signal. Another is that calcium also has a role in the termination of optic signal. So calcium, what does it do? It increases the activity of enzyme guanylylate cyclase. So guanylylate cyclase will convert GMP into cyclic GMP. Okay, so more formation of cyclic GMP will lead to opening of sodium channel, and that will lead to termination of optic signal. So if there is a question like only Wald's visual cycle in 5 marks, then you have to draw a particular cycle that we already explained. After that, you have to write the two another things, that is the generation of optic signal, and second is the termination of optic signal. Okay, so if there is a question exclusively on Wald's visual cycle, you have to write the generation as well as the termination and the cycle diagram. Now continuing the functions along with the function of vision, you have to understand few other another terminology. One of them is the dark adaptation time. So what is the dark adaptation time? Is that sometimes if you see, suppose from a lighter area, if you go onto the darker side, okay, so suppose if there is a sudden uh, lights are off into the room, or suppose if there is power cut at the night, then for sometimes it takes some time to see the all the things in the dark. It takes some amount of time. Similarly, you can experience the same thing when you visit any theater. So from the light, as soon as you enter the theater, it takes few seconds for you to see the theater seats or few other things, the staircases. Okay, so that is the time which is required to form the rhodopsin. So what happens when the person shifts from brighter light to darker light? The rhodopsin starts to break down. Rhodopsin stores are depleted and vision is impaired. But after some times, if rhodopsin is resynthesized, then vision starts to improve and we starts to see the things clearly. So this is known as the dark adaptation time. That is the time which is required to see the things proper when we go to bright light to dark light. So if there is a vitamin A deficiency, then it takes some more time to see the pictures. So it increases the dark adaptation time or adaptation time which is required to see the things in the darker arena. And continuous deficiency of vitamin A will lead to night blindness. That means the person will not able to see in the dark light or particularly after evening. So that can be seen even in the few old age people when there is a depletion in the stores of vitamin A. So similarly, visual cycle is also taking place in the cone cells also, and in cone cells which are responsible the color vision, they have a different pigment. In rod cells we had only one pigment, that was rhodopsin. In cones we have three signals, that is the porphyrosin which is responsible for the red color, synopsin for the blue, and iodopsin for the green color. And if there is a deficiency of any one pigment, then that person cannot see that particular color, and which the condition we call it as color blindness. So suppose if color blindness, which is common even in normal healthy individual, so if suppose a person cannot differentiate or cannot see the blue color, then there are chances that if there could be deficiency or absence of this particular pigment synopsin. Similarly, if there is a deficiency of respective pigment, then person cannot see the red or green color or cannot differentiate the colors. If we see the other functions of vitamin A. So apart from the vision, this retinol and retinal, which are interconvertible, they have a role in maintenance of reproduction. That means they helpful in maintenance of germline epitheliums. So the gonads function and the maintenance of that reproduction function, for that vitamin A is must. Also they helpful in the growth. They also helpful in differentiation and maintenance of epithelial tissues. Also they are responsible for the integrity of skin, particularly the retinoic acid. So retinoic acid and their ointments are available in the treatment of psoriasis, where the main defect is the skin peeling. Also, in your age, there are problems of acne or the pimples. So if you are using any treatment or you can say ointment for the treatment of acne, if you see that it will contain a retinoic acid or retinol derivative. Also they are helpful in treatment of promyelocytic leukemia. Other functions of vitamin A, you can see here, it also acts as antioxidant. So it helpful in prevention of free radical injuries, so it reduces the risk of cancer as well as the heart attack. So apart from vision, you have to remember the other functions such as the growth, gonad integrity function, differentiation function, and the skin maintenance function. So deficiency of vitamin A, one thing we already discussed, it can lead to night blindness. Another thing, it can lead to xerophthalmia. So what is xerophthalmia? It's a dryness of the conjunctiva, which is one of the layer of the eyeball. So on the dry, there are high chances of infection, and conjunctiva becomes, there can be wrinkling, and there will be keratinization loss. Okay, so that is the process where conjunctiva loses its transparency and can lead to infection. Another thing is the Bitot spot. It's a grayish white triangular plaque firmly adherent to the conjunctiva. So images of that we will see in upcoming slide. Then there will be, next stage will be the keratomalacia. So there will be softening of the cornea, and it will lead to development of corneal opacity. Then finally, if things are not changed or reversed, then there will be blindness. Also on the skin and mucous membrane, skin become rough and it can become the frog-like skin, which is known as the phrenoderma. And general manifestation of any vitamin deficiency like growth retardation or failure of the skeletal growth also will be there. So if you see this particular few eye related deficiency features of vitamin A, so this is the Bitot spot, this triangular patch in the conjunctiva. Then this is the dryness of the conjunctiva will leads to infection. So this is known as the xerophthalmia. This is the corneal opacity, the condition which is known as the keratomalacia, and this is the phrenoderma when there is a development of rough skin. So if we describe the stages of vitamin A deficiency related with the eye, it starts with the night blindness. Okay, then there will be xerophthalmia, then there will be Bitot spot, and then there will be keratomalacia, and still vitamin A deficiency persists, it can lead to blindness. Finally, the toxicity. Toxicity is can be seen in children. So the symptoms are very nominal. They're like anorexia, headache, vomiting, drowsiness, etc. etc. There can be swelling over the long bones along with the pain. There could be hepatomegaly because of the storage of vitamin A, and the skin can become yellow by consumption of food which is rich in carotenoids. So hypervitaminosis, it is not that common, and you don't have to focus much on hypervitaminosis, but the deficiency part you have to remember because it can be asked separately. Also it's one of the main portion if the vitamin A is asked in long question format. Okay, so that is about the vitamin A. Thank you very much.